What's up, everybody? I'm Dr. Jordan Taylor, the Undergraduate Exercise Science Program Director and Associate Teaching Professor at the University of Kansas. Speed is critical to an athlete's success in many sports because the ability to outrun the competition is a hallmark feature of most athletic endeavors. Speed can be defined as the skills and abilities needed to accelerate and achieve high movement velocities. Sprinting is a series of coupled flight and support phases known as strides, performed in an effort to displace the athlete's body down the track, field, or court at maximal acceleration or velocity, or both, usually over short distances and durations. It's important to understand that sprint speed is concerned with the relationship between stride length and stride frequency. Knowing this, sprint speed can be increased by increasing stride length or increasing stride frequency. More successful sprinters tend to have longer stride lengths, which results from properly directed forces into the ground, while also demonstrating a more frequent stride rate. The underlying component to maximizing stride length and stride frequency is related to rapid force production. Elite sprinters produce larger forces into the ground during a shorter period of ground contact time as compared to novice sprinters. Rate of force development is a measure of explosive strength and can be defined as the change in force divided by the change in time. Developing an athlete's ability to display maximal force in a minimal amount of time is desirable for success in sprinting and improving the overall speed of athletes participating in a variety of team sports. Rate of force development and proper sprinting biomechanics or technique are two of the primary limiting factors influencing sprint performance. So today I have strength and conditioning coach Joseph Potts joining the show again. We're going to discuss the training methods he uses to develop speed in athletes and examine proper sprint mechanics in the various phases of sprinting. Coach Potts will also provide practical tips for athletes who are looking to improve their sprint technique and coaching cues that can help improve sprint speed. I've had Coach Potts on the show before, but I want to provide some information about his background again before we dive into the discussion today. So Coach Potts owns and operates TopSpeed Strength and Conditioning, a private sports performance training and physical therapy center in Lenexa, Kansas. Coach Potts is a registered strength and conditioning coach through the National Strength and Conditioning Association and a corrective exercise specialist through the National Academy of Sports Medicine. He holds a bachelor's degree in exercise science from the University of Kansas, where he played for the KU football team. So welcome back to the show, Coach Potts.
I appreciate it. Glad to be back.
And speaking of football, I guess we were out eating not too many weeks ago, and we figured out that we would have actually played arena football when you were playing and I was playing back in 2005, except so you were out playing with the Kansas Coyotes in Topeka, and I was down in Wichita with the Aviators. Except we both had injuries early on in the season, so we didn't get a chance to actually play against each other. So that was just kind of interesting. We didn't even realize it. I know that year I started out with hamstring injuries, and you had one of the craziest hip injuries I think I've ever seen, where he basically sheared off the top part of his femoral head, the ball that fits into the hip socket. And that, looking at those X-rays,
yeah, not a lot
crazy.
of fun. I mentioned while we were walking up here the hospital stay. So I actually was immobilized from the waist down because they said if I tried to turn over while I was asleep, that it would have redislocated or potentially re-sheared that head off. So they had me with a giant foam wedge, and I was strapped down from the waist down.
And it's just you were running with the ball over towards the wall and got hit?
Yeah. So I yin and yang of the whole thing. I happened to be really big and really fast at that time of my life. And, was in to carry the ball, rolled out from the quarterback position, took off, took a tackler low, mid, and high, had that leg planted in the ground. And Dr. Boer, who did my surgery, essentially goes, you were too strong for your own good. Like the muscle, the strength didn't fail. The connective tissue did, and that it just rolled over inside the socket, came out. As I landed on it, the edge of my pelvis took the head of the femur off. Partway through, it wasn't even like at the neck. It was.
And then you injured it again, and now you need a hip replacement. See, we got to get you back to top speed. That's what we got to.
That's true. It'd be nice,
especially to keep up with your 3-year-old Jax. Got to get back to top speed. So
that kid he's like Dash from The Incredibles.
I've seen your costumes for Halloween.
Yeah.
I know you guys go big for Halloween. So, all right, let's get into the discussion questions. So, just this first question here. So to become fast, we know an athlete needs to be strong. They need to display force rapidly. They need to be mobile. And
not too mobile.
Right, but not too mobile. Yeah. It's a balance between stability and mobility for sure. They need to practice sprinting with proper technique at maximal velocity. And that helps to create neuromuscular adaptations responsible for improving sprint speed. And then obviously good genetics, having a lot of type 2, fast twitch muscle fibers, that plays a huge role. You can get into the whole argument of are sprinters born or made? It's a little bit of both, but definitely if you have a lot of fast twitch muscle fibers, you're going to be pretty successful.
There's research coming out that's a trainable element as well, which at least whenever I was coming through school, was the opposite of what we were taught. It was, hey, you were born with what you're born with.
Right.
You can't. And now we're seeing these studies come out of Spain and other countries where it's like, well, if you actually, heavy weightlifting is the trigger. If you do heavy weightlifting and then you back off of it for an extended period of time, you'll see some shift.
Yeah, to the type 2.
Yeah, type 2X,
to the type 2 fast twitch fibers. And some of that, I was talking to Dr. Fry here in the Jayhawk Athletic Performance Lab about it because he's done a lot of fiber type research through the years. And we were talking, he's like, yeah, you can. And there's so many hybrids. It's a huge spectrum. It's not just type 1, the slow twitch, the endurance fibers that are very fatigue resistant, but those slow twitch fibers don't produce a lot of force. And it's not just the type 1 slow twitch, and then you have the type 2s that are the fast twitch. They fatigue quickly, but they can produce a lot of force. Elite sprinters tend to have a bunch of them. There's all these hybrids in between the type 2A X's that are a little bit type 2A and a little bit 2X, and then there's the ones between the type 1 and type 2A, and then there's more hybrids in between those. So he has this great slide that shows this whole spectrum, and depending on the type of training you do, you can get some fiber type shifts. So if you do a lot of plyometrics, high intensity, heavy weight training, sprinting, you may have a shift in the properties of your skeletal muscle tissue to more of a fast twitch fiber type. Whereas if you're, doing a lot of endurance training, lighter loads, not as much heavy weightlifting in the gym, maybe you're not doing as many explosive plyometrics and things, you may have a shift more towards that type 1 slow twitch muscle fiber type. And like you said, when I was going, and we're about the same age. When I was working on my bachelor's degree in exercise science, I remember we learned it as you did. It was like your fiber type was pretty much set. Now we're seeing, like you said, there can be some switch where those fiber types can take on different fluid characteristics depending on the training you do. Also then, if we talk about, tying into this question, what are some of the training methods that you use at TopSpeed to improve, an athlete's obviously getting stronger, their ability to display force rapidly, proper sprint technique. So just overall training some of those components.
Yeah. So the first thing we do during our intake session is we do a really kind of remedial force velocity profile using the vertical jump. And that kind of will guide the decision-making process when it comes to volume. Load, I've been at it long enough. I typically know the load I want to use with kids, but it'll help guide that volume. And it's really not much difference. One set's roughly 20%, so there's 20% differential. Kids who are naturally elastic, fast twitch, we might have them do an extra set at the higher intensity with more weight, versus kids who tend to come in strong but slow. We'll take the opposite approach, and we'll underload them and have them do more velocity dominant movements, things like that. So that's the initial intake we do there. Outside of that, we tend to focus on a lot of unilateral and isolateral training, because that will carry over to bilateral versus bilateral training, which doesn't really have the carryover to the unilateral. And typically on the field, everything you do
and sprinting is basically unilateral bounding. Yep. I mean, that's what you're doing. Yeah.
So our primary goal with kids, because our biggest spectrum of athletes are high school. Most of them lift in a school setting, so that box is checked for the most part. The quality of training, obviously, there's a huge spectrum.
It's going to vary
there.
from the coach that's working with them, yeah.
But for the most part, we can focus on just raising the horsepower that they're capable of outputting. So that's, at least in what I call our phase 1 and phase 2 programming, that's the main goal, is improving horsepower along with their ability to tolerate higher levels of force and power output. Whenever it comes to like top end sprinting, we'll use a lot of the fly 10s at different run-in lengths. Depending on the athlete, obviously softball players have a pretty short distance that they'll cover. So we might use like a 10-10 fly for them. Football guys tend to respond well to that 30-10, baseball 20-10, things like that. We don't really do a lot of typical strength training, which is funny. I was working with a professional volleyball player recently, and her vertical jump, she was a transfer from UCLA. She actually had not set a new PR since her freshman year of college, and she was 5 years in. And she did while we were training prior to her leaving for Europe. And she goes, man, I feel like this is crazy because we've done all this training. I was always told, hey, if you can get your squat higher, you're going to jump higher, you're going to produce more power. And she was like, I haven't been under a bar since I've been here. Mm-hmm. And I was like, well, yeah, that's because you have that box checked.
Right.
So, we know, thanks to Dr. Ree, that once you're capable of squatting more than 1.7 times your body weight, like anything over that just makes you a better squatter versus more powerful. So we worked on rate of force development, things like that.
And that ties in, the rate of force development is so key, like I mentioned, kind of reading through the intro there. Typically we know it takes about a half a second to produce maximal force. But when you're sprinting and you look at the time that the foot is actually in contact with the ground, it's typically around a tenth of a second. Yeah. Elite sprinters, it may be less, like 0.08 of a second.
I was going to say.
Novice sprinters, it may be a little bit more. So if the foot's only in contact with the ground for, say, a tenth of a second, but it takes a half a second to develop maximal force, in that tenth of a second, you don't have the time to produce your max level of force. So you've got to be able to produce whatever force you can very rapidly in that tenth of a second. And that's rate of force development. Yeah. And, that's where it's so important. And, that's obviously trainable. You train things like plyometrics. Yeah. And obviously you need to sprint at max velocity to develop that and to learn how to produce that propulsive force into the ground very rapidly. And so I think that's very important that, and we get into so often thinking about training muscles. But there's a huge neurological component to train here with sprinting that, just like with sprint technique, I talk about this in my classes that, we store, you can look at, you think of the nervous system. You've got the central nervous system, the brain, the spinal cord, and then the peripheral nervous system. So your motor nerves that leave the spinal cord go out and activate muscles, sensory feedback coming in from the muscles about muscle tension and stretch coming into the spinal cord and up to the brain. So there's all these different pathways. But if you look at, let's say, training sprint technique, right, and you're working on somebody's running form, I think with kids, and I'm trying to work on this with my daughter, like when I work with her, I want her to learn the correct movement patterns because I know that if you learn movement patterns improperly, you store these as what are called procedural or implicit memories in the brain down in like the basal ganglia. So these deep structures of the brain, and there's connections with the basal ganglia to the cerebellum, the motor cortex, all these brain regions. But you don't want to store an improper motor program or improper movement pattern, because then when you have to activate that movement, you're going to just kind of unconsciously, automatically activate a faulty movement pattern, faulty mechanics. Yep. So it's so important, I think, and I'm sure you do this with youth. It's like, let's teach you how to the form correct, or at the beginning, let's teach you the correct form so you store that proper movement pattern in the brain. And then it's basically activating the motor program.
Muscle memory.
Yeah, exactly. That's what it is.
So we have a very good youth athlete coordinator. He works with our clients we see that are in that 6 to 11-year-old range. He's really good. And the reason I actually had avoided that for years when I started the business, and I just recently, within the past 5 or 6 years, integrated it. I had a talk with Al Vermeil during one of the NSCA conferences. And then expanding on that, I saw it echoed by guys like Joe DeFranco and in some other research. And they said that kind of the primary window to set those movement patterns is like 6 to 11. Mm-hmm. Al said that, he started with his son too late. He was like, by then his ceiling was already set. He was like, I feel bad because I kind of limited his potential because I waited until he was about high school age to introduce him to some of these things. He was like, I really wish I had started sooner.
Yeah, and then interesting that you move down from the brain and the spinal cord, and we were talking about this on the ride over, there's what are called central pattern generators. And these are really interesting. So they've shown in research going back to even like 1911 into the 60s, looking at research in cats. So obviously, if you think of the brain, it's sending action potentials and nerve impulses down the spinal cord, down these descending tracks. And then from the spinal cord, you have these motor nerves that carry that signal out to muscles to activate them and recruit them in the appropriate manner to do whatever task you're trying to do, whether it's shoot a basketball, sprint, whatever it is. Well, they saw that in cats, if you could basically remove the cerebrum, the cerebral cortex, the brain, you're basically cutting off the brain, the motor cortex from the spinal cord. But if you either electrically stimulate the spinal cord or you have them walk on a treadmill, as the treadmill's moving underneath them, there's sensory input going into the spinal cord, activating these central pattern generators. They're kicking back out. They're activating motor nerves and kicking out action potentials back to the muscles involved in walking, and they could produce a stepping pattern just at the level of the spinal cord. Now, obviously, if you threw a log or something on the treadmill and they had to step over it, they were going to trip and fall because that requires the brain to consciously, there's a log here, I got to go around it. But it's just kind of interesting. There's this component within the spinal cord, these central pattern generators, and they've seen this in spinal cord injury patients where maybe they have a high-level C-spine injury. The signal from the brain coming down to produce certain movements isn't getting through. But if you electrically stimulate the lumbar spinal cord and the low back, and you've got this spinal cord injury patient laying on the back, the legs will kind of produce this flexion and extension stepping pattern. And so I just think, it'd really be interesting. I have to dive into the research. Joe Weir from our department might be good to talk about central pattern generators, but it's like, does sprinting and proper sprint mechanics strengthen those inner neurons and the synaptic connections between neurons in the spinal cord, and then strengthen connections with motor nerves that are leaving the spinal cord and going to, muscles of the hip and, the quad, the hamstrings, the calves, and then sensory input, the sensory nerves coming from those muscles back into the spinal cord. It's like a loop from the spinal cord to the muscle and back. And I'm sure, I'm just saying this anecdotally. I don't know. I'd have to really dig into the research, but I would think, training proper mechanics, drilling proper mechanics may help strengthen some of those connections, synaptic connections between those neural networks, those central pattern generators in the spinal cord that help produce rhythmic locomotor activity like walking, sprinting. They're involved in swimming, any type of activity where it's very rhythmic.
Yeah. I mean, it makes perfect sense because if you think about it, paralysis by analysis, athletes hear that all the time. Mm-hmm. If you're thinking, you're slower.
Right.
If an athlete is sprinting and they're thinking, okay, am I dorsiflexing the foot? Am I reaching my landmarks with my knee, my hip flexion, my arm action? They're at a neurological level slowing themselves down.
Right. Because it really is an automatic behavior. It's not something that you should be consciously aware of. And this is why, like I said, it's stored in areas of the brain as a, procedural memory, these movement patterns. It's not something you have to be consciously aware of and think about. Yeah. I mean, we didn't think about walking in here. We didn't think about when we parked in the parking lot here at KU and walked into the building, I got to put my left foot forward and flex my hip.
I was like, this is a long walk.
Right,
it's a long walk on this hip.
Right. But it's like, it's an automatic behavior. So you'd think you can strengthen that automatic behavior with drilling and proper sprint mechanics and strengthening those connections. I just think it's something overlooked. That's why I bring up this neurological component, because so many times I think coaches are just thinking train muscle. And it's like, well, what activates muscle? Motor nerves. Where are they coming from? The spinal cord. What's in the spinal cord? Central pattern generators. What's upstream of that? all these different brain regions, the motor cortex, basal ganglia, premotor areas, cerebellum, they're all sending information down the spinal cord. So you've got this flow and this network, and it's overlooked.
At the base level, sprinting should be a reflexive movement. I mean, fight or flight. If you were out as a hunter-gatherer and you came upon something that higher on the food chain than you are, you want it. It's got to be reflective. You can't think, oh man, I better get my step pattern in check. I better get my arm action because you're dinner.
Right.
It needs to be hindbrain.
And I think that's where, coaching cues, we'll get into these in a bit, but they need to be very simple because you don't want the athlete thinking about, like you said, I got to dorsiflex the foot and, I need to have higher knee drive, or, I'm not planting the foot 4 to 5 inches in front of my center of mass. And it's like, no, you're overthinking. So and I'm sure you'll give some really good coaching cues that you use with your athletes that allow them to sprint more effectively without thinking about what they're doing and trying to correct the technique. And then it's like, well, with some sprinters, do you really want to correct the technique? That's a whole other topic too. Let's see. So other things that with training at top speed, and we'll kind of finish up this first question here. Let's talk about the difference between, and maybe you can define these, speed strength and speed endurance. So what is speed strength? And how might you help improve that in an athlete that struggles with their speed strength?
So, kind of to give some background, the different phases of sprinting are all influenced by different athletic qualities. For example, your 0 step tends to be really, really...
Can you tell everybody what 0 step is?
It's that first stride where both feet haven't left the ground. One is actually in cycle, in phase. That short acceleration window tends to be highly influenced by strength. Rate of force development is a factor, but strength, we know, based on the results of research, it plays a big role.
Yeah, because you got to have the strength to overcome your body's inertia, your body's resistance to a change in motion. Yeah.
So from there, you've got early acceleration. Again, strength plays a role, but it starts to have less of an effect. Rate of force development is they're syncing up, they're meshing. Then you've got late acceleration, which actually tends to be very rate of force and body angle dependent.
Right.
Where are you projecting that energy into the ground?
Yeah, the vector that you're producing, that propulsive force.
Yeah. And then you hit your transition phase, which out of all the phases is typically the shortest. That's that one where you're in acceleration, the hips are behind the body, but they're coming up underneath. Mm-hmm. And then
raising your center of mass.
Yeah. Getting it under you, stacking the spine. This is where the landmarks, the technique starts to become more important. Typically in this phase where transition, we're doing longer sprints to train it, but they still might be tethered to something, but it's a pretty low resistance. I like hills a lot for this, to be honest with you.
For speed strength? Yeah. Resisted sprints, things like that.
Mild resistance, a little longer distances than you might do for traditional acceleration training.
And we'll talk more about resisted sprint training in a bit, loads that should be used, things like that. So now moving on to speed endurance. So some athletes struggle. I'll use myself, for example. I know when I ran 40s, hardly anybody could beat me in the first 10 yards. I was great out of the, off the line, great with acceleration. I had more trouble with speed maintenance, like my speed endurance. Yeah. And, talk about how you might work with an athlete that struggles with speed endurance.
So we know that to train speed, you need to be operating in the 95% plus threshold in relation to your max output. So with speed endurance, what I like to do, this is one, I'm not big on like parachutes, because the most influential phase is going to be that initial acceleration. That's always the slowest, that's the easiest one to manipulate. So I've never been big into parachutes, but when it comes to speed endurance, that's where I like them. Because if I'm working with you, you're an athlete.
And what distance are you covering with that parachute? So that's the next question.
That will typically be 20 to 60 yards, even up to 80. I've used with guys. And it's, hey, you're going to hold it. You're going to run about 3 to 4 steps in. I want you to let that thing go. By then, you've overcome that inertia. You built up some momentum. The wind can inflate it. And we're going to work on speed endurance. We know your max output. Now we know what it should take you to get from A to B. Now I want you to be within, 85, 90, 95% of that, but you're towing this thing.
Yeah.
There might even be some kids you might use multiple parachutes with. You see that in a lot of like elite.
And some of it I think can come down to energy systems too. It's like, well, speed endurance in 100 versus say a 400 meter race, that's a lot different.
Oh,
I mean,
huge.
You start running, you're talking speed endurance in a 400 meter. It's like, well, now you're not just relying on phosphocreatine like that you would rely on as a fuel source for the first 10 seconds. The 100 meters is pretty much pure phosphocreatine for your fuel source. You get into running the 400, now you've got the glycolytic system getting involved, and so then maybe it's doing some of that energy system specific training.
And fueling with the right things. Because like you said, the energy systems, we know that phosphocreatine system, well, once it burns through that, it's got to move on to a different fuel source. But that's probably a discussion for
that's a whole nother, we go on so many tangents here. I got to stay on track. So I think maybe, anything else you want to add to this first topic, first point?
I think we covered it. I mean, you asked what we do. It was in relation to speed endurance.
Yeah,
I think we covered that.
All right, so let's move on to the next one. So, I mentioned earlier that improving sprint speed is a product of increasing stride length and or stride frequency. Is it easier to improve an athlete's stride length, or is it easier to improve their stride frequency?
And I know you already know the answer to this, but stride length by far is the most influential. We talked about this on the car ride over. There's not much difference in the cycle time, novice sprinters versus elite sprinters. It's not a huge difference. Does it matter depending on how many steps are in the race? Yeah, and it accrues and becomes a factor. But as far as that goes, I read this a long time ago, and I forget who did the study. It might have been an anecdotal thing from a media outlet. I honestly can't recall. But it was a penny. During a 40-yard dash, if you can lengthen an athlete's natural stride by a penny,
the diameter of a penny,
it will cut 2/10 off the end of their race time. So, but like I said, it has to be a natural stride. You can't have them casting the lower leg, heel striking, because then that's a braking force. They're going to slow down. Whenever it comes to those two variables, stride length, obviously the biggest thing. Stride frequency tends to be, in my experience, primarily influenced by technique.
Yeah. And, it's funny you mentioned 0.2 of a second. For some people, if you're an athlete, or you'll say, I know you work with NFL guys, getting them ready for the combine and stuff, that 0.2 of a second, that's a big amount of time. It doesn't sound like a lot, but and how this affects your draft stock too. It's like if you normally run a 4.3, and then on, a pro day, or you're at the NFL combine and you have an off day and run a 4.5, maybe you were a first-round draft pick, and now you've fallen down to third or fourth or fifth. So that, and if two people are racing, let's say in a 40, and one person runs a 4.3, the other one runs a 4.5, you're looking at a difference when they cross that 40-yard mark, that finish line, of about 1.5 yards. I mean, so 0.2 of a second is...
it's a substantial time whenever you're seeing the numbers on the clock.
Right. Yeah. I just thought I'd mention that point, because some people, will hear 0.2. Well, that's not that big of a difference. Well, it is when you're talking about a 40 or 100-meter sprint. That is. All right. So with talking about stride length, like you said, we know that just your body anthropometry, the limb length, your height, that's a major factor in your stride length, right? Taller people naturally going to have a greater stride length. Right. However, even somebody short like me, I'm 5, 6 on a good day. I can train to increase my stride length, right? One of the ways of doing that is just getting stronger and being able to put more force down and back into the ground, and it propels you further forward. So with that said, what training methods do you use to increase stride length?
So again, it kind of depends on the athlete. Well, it always depends on the athlete. But, if they're weak, we get them strong. If they're strong, we work on do they have any issues in mobility?
Yeah.
Because guys tightness isn't always a bad thing, but too much tightness is.
Right.
So we might work on taking them through extended range of motion under load, help improve that natural mobility
and having good hip flexor range of motion.
And that's the one I had in mind was a front foot elevated reverse lunge off of a 6 to 12-inch box, depending on the kid. That one's kind of a key exercise in working that hip mobility. Big into plyometrics, especially like a unilateral, isolateral plyometric. Big into those. The other thing is
just like bounding. I mean, something like bounding, as simple as that, down the track.
One I really like right now is single leg depth jumps. Off a box, hit the ground, minimize ground contact time, get up onto the other one. And then something that I'll do, I don't really do it too much with younger kids, like underclassmen, but upperclassmen, collegiate, professional that I've gotten into is tissue integrity. Because the tissue has to be able to store and tolerate that force. I mean, I'll be honest, I think that's why you see a lot of Achilles injuries in NFL athletes is they might work a lot on force, power, etc., but are they working tissue integrity? Jorge Carvajal and I had a discussion years ago where we were talking about the fiber matrix inside, the Achilles tendon. So we'll do some isometric work to target that. But like I said, I kind of reserve that for the upper level. Yeah,
because tendon stiffness, it is trainable, and there's starting to become more research on looking at tendons and tissue integrity, and for so many years just focused on muscle. But yeah, tendon stiffness is a major player in kind of that elastic, stretch shortening cycle. So if you think about, the Achilles is connecting the calf muscle to the heel bone, the calcaneus. And when the calf stretches and the Achilles tendon stretches, you can think of it as like a spring, right? It's going to lengthen out. And then when that heel comes off the ground and the calf contracts, you're getting this reflexive, elastic recoil release of energy, kind of like a slingshot.
Yeah.
It's literally helping slingshot that foot back up off the ground. And having adequate, we always talk about stiffness. When you're sprinting, you want some proximal stiffness in the hip. You want some distal stiffness down around the ankle. And that gastrocnemius, Achilles, that calf complex, because that's going to help to adequately transfer that force into the ground. So that's where you said it's important to have that balance between you want enough stiffness within the system, but also enough mobility so you have that stride length.
People hear the word stiffness and they inherently go, "Oh, that's a bad thing. I don't want to be stiff." And it's you kind of do, because you want to be able to transition that elastic energy.
And you want to be stiff at the right phase of the sprint cycle, right? It's you want to be stiff when you're driving that leg down into the ground, but then in the recovery phase, you want to be more relaxed.
Yeah.
So there's this balance of stiffness and relaxation when you're running too that I think that's hard to teach young athletes. Somebody, they run tight and it's hard to teach that you've got to relax at certain points but be stiff at other points, especially stiff when you're putting force into the ground.
And on the ride over here, and we were discussing this, and I use that analogy of you'd rather strike the ground with a steel-headed hammer versus a rubber mallet. And that's when I mentioned earlier, hypermobility. Some coach put it to me, the people with the lowest vertical jumps tend to be like yoga instructors.
Yeah.
Because they're a lot of them are
they're like Gumby. Yeah. And I like to use the analogy of it's like a yo-yo. If you think about your legs when you're driving them back down towards the ground, if you're playing with a yo-yo, you use some force to get it going, and then the string unwinds, the yo-yo's spinning at the bottom, and then you only need a little bit of force. It's just to bring it back up, right? And that's kind of like the analogy with driving the legs down and into the ground and then recovering and that knee drive that you see.
And you've got some reciprocal forces helping you do that with the arm action and things like that.
Right.
Yeah. You don't want to be thinking about it.
Right. All right, we're jumping all over, which is good. Yeah. Good discussion. Let's see. So, like you said, for increasing stride length, you like to use things like uphill running, resisted sprinting. What about sleds? You do sled work, sled pushing, sled pulling.
That's kind of what we're known for, is our sled. Yeah. I don't know if we were like one of the first facilities around here to incorporate it, but that's we have a reputation based on our sled work. So going back to those phases, so I'll just kind of break it down into the phases. That 0 step, again, really malleable with strength. So we'll use lunge variations, rear foot elevated squats. We have different, I don't know if I invented these, but I haven't seen other people using them. We'll use what I call 0 step repeats on the sled, where the athlete has, we use the Rogue Butcher style instead of the Prowler. I feel like the Prowler, the bars are a bit too wide.
Yeah.
So I like a shoulder width. So those Rogue Butchers.
Right, because you're not sprinting, your arms aren't aren't out here.
So I'll have them put their shoulders up against the pipe, so they're at a good drive angle. And it's like, look, you got 2 steps to cover as much ground as you can, and that's just because they're reciprocal. So I call those 0 step repeats.
Okay.
Bang bang.
Yep.
Now stop. Let inertia set in. Same thing. Bam bam. So that it's essentially micro sets inside a bigger set.
It's like a cluster set for the acceleration phase of sprinting. Yeah.
And then we'll do another one where it's the same setup, but I take a leg away, and I'm like, all right, you've got one leg to drive on. So it's essentially a series of angular bounds, and we'll look at that shin angle. Hey, you don't want to be too high, because then you're not going to get anywhere. All your energy's projecting upward. You got to find that happy medium, 40 degrees or so, where you can project horizontally.
Right. Yep. Obviously important, those front side mechanics and that acceleration, that drive off the line or off the starting blocks. We'll discuss those. What type of load are you using for that when you're doing those 0 step repeats?
It really depends on the kid. Honestly, I tell the kids, challenge yourself. You need something that's tough but doable, and that range.
And just where you don't see like the form just looking totally broken down.
Yeah.
Obviously.
So I know one of the pictures that we'll show later. It's a guy 0 step out of the 40, and you can see his hips are actually rotating, which less than ideal. It's going to take time to reorient those hips and get a neutral pelvis. We don't want to see a lot of rotation in the pelvis. Don't want to see the back rounded, things like that. Whenever it comes to those exercises, that's the approach.
All right. So then moving on to, and I know we're kind of getting into question 4, which was about the load that you use in resisted sprints. Obviously, you don't want the load to be too great to where it negatively affects running kinetics, kinematics, and overall technique. I know the National Strength and Conditioning Association, which we're both certified through, they have a lot of recommendations that most of them I agree with. They recommend external loads that are less than or equal to 15% of an athlete's body mass to perform resisted sprints over short distances like 10 to 30 meters. Do you agree with that general recommendation or not? I know like Asafa Powell and other Jamaican sprinters, they've used some pretty heavy resisted loads during like sled sprints and things like that. So, these are guidelines. I mean, what are your thoughts on the guidelines? Do you ever go above 15% of an athlete's body mass?
I think this, because I've seen this debate all over social media throughout the years. I think this right here illustrates the disconnect between academia and research and coaches with boots on the ground.
Yeah.
I actually disagree wholeheartedly. Cam Joss, who now is at Auburn, did some research that he published in Simply Faster. And he talked about he had 2 NFL running backs he was working with, and he talks about letting the velocity dictate the load, which, essentially velocity-based training, that's the whole thing.
Right, you're tracking the velocity to dictate.
But instead of doing it with a barbell, we're doing it with load on a sled. And I actually read his article last night, and he said one of the athletes, their 50% velocity occurred at 82% of their body mass. And don't quote me on these. I'm trying to remember them off the top of my head. But, I want to say one of them was like 82 to 90% versus the other guy was in the 70% zone. But both of those are well outside that 15% recommendation.
Yeah. And I think in general, and I'm sure you'd agree with this, you would want to use heavier resistance or heavier loads, like on a sled, if the goal is to improve acceleration, but use lighter resistances, say on the sled, if your goal is improving max velocity.
Yeah.
Right. So,
and that's what he talked about. He used a 1080 sprint to kind of measure it, but unfortunately I forget the distance they were measuring. I'm sure based on the numbers, it was acceleration, probably sub 20 yards.
Right.
Obviously as you get into the lighter, the longer distances, and I had this note to make in question 3 was, whenever it comes to like late acceleration stage. Well, some of the exercises I like to use are 20-yard plus sled runs, shoots, things like that. Top end, I'll use wickets. Longer hill runs of longer than 6 seconds, things like that.
All right. And then what methods do you use to increase stride frequency?
So I'm a big believer that stride frequency is primarily a technical thing. You and I have talked about this before. Are you
big neurological component?
Yes.
How quick is that signal getting from the spinal cord via the motor nerves out to the appropriate muscles to, how fast are they getting recruited and rate coding? This is literally the firing rate of action potentials along a motor nerve that's going to a muscle. And
you and I talked about this on the walk up here. That's where I feel like overspeed training has its biggest impact, is that neurological side of things. The technical side, it's going to vary with, like you said, the limb lengths of each person. But
maybe can you tell everybody what is overspeed training?
So overspeed training is taking an athlete and towing them at a supramax speed. So we're fortunate in my facility that we have a 1080 sprint unit, which I don't know how many are in America now. I know at the time when we got it years ago, they told us there were only like 17 in the country at the time, and they were primarily at schools doing research.
And again, this unit just allows the athlete to run at a velocity that is greater than what they would normally run at if they were unassisted.
Yeah. So we did a pilot study a couple years ago where we would tow them at 105%. I think maybe 110% we got to based on their initial testing. And we saw some pretty good carryover in the how it impacted an athlete's ability to overcome inertia and really get going. We used it for acceleration. I didn't go very far. I didn't have the length in my facility to go very far.
Right.
So I was looking at that 0 to 5, and it was pretty stunning, the results there.
Yeah, and if you don't have, a cable, any way of towing the equipment, you can always use downhill running. Obviously, gravity is going to help allow you to run at a faster velocity. Now, you don't want to use a hill that has too much of a downward degree slope. You're looking at maybe 1, 2, 3 degrees
I would
max.
say 3 at most.
Yeah, because if you start going beyond that, your mechanics are going to break down. There's a lot of eccentric loading and stress on the body. It can make you really sore. You'll be a lot more sore running downhill than you would after running uphill. Because your turnover rate, like I said, it's going to allow you to, with gravity kind of pulling you down the hill, get those legs turned over faster than what you normally would if you didn't have gravity assisting you.
Going back to what you were talking about with the coding, if you introduce that element at too young of an age, what's the natural thing to do when you're sprinting downhill? Heel strike.
Yeah.
Because you want to apply a braking force. You don't want to get out of control.
Yeah, you don't want to do a face plant.
Think if you're doing that with kids, 6 to 10 years old, and that's what's encoding itself in the movement patterns.
And then you learn to sprint. Negative. Then you learn to sprint by heel striking instead of striking with the ball of the foot.
Yep.
You should, which obviously we're going to see a great video here at the end of a athlete from K-State running in slow motion, and you'll literally see how he strikes with the ball of his foot, which is what you want to do. I hate it. I'm going on a tangent now. I can't stand it when I hear, a high school coach or college, whatever coach, and they say, you want to run on your toes, and I just want to pull my hair out. I'm like, no, your toes don't produce a lot of force into the ground. You want to strike the ground with the ball of your foot.
The joint of the big toe.
Yes. So anyway, that's...
I get why they say it.
Right.
It's an easy cue. But, if you were a bit more specific, and even go up to the kid and show him, like, hey, look, this is the head of the hammer. Strike the ground with that.
And speaking of striking the ground, I know we're going to talk about some of this when we get to the pictures of the different phases of the sprint cycle, but how do you coach your athletes? Do you coach them to strike and punch at the ground down and back, or do you cue them to claw at it?
So, more punch. Punch. The one kids have heard me say 100 times is it's a punch analogy. And typically we're talking about hip flexion here, but I ask them, all right, if you're a low hip flexor, I come up to them and I'm like, if I'm going to punch you, am I going to hurt you more if I throw a jab or if I cock back for a haymaker? And all of them are like, well, the haymaker. And I'm like, why? Well, it's got more room to build up force, momentum, whatnot. I'm like, it's the same thing when you're sprinting.
Right, now you're talking impulse. If you're cocked back here, more time it's going to take to get from point A to point B, but over that longer time frame, you can generate more force.
Much more. Yep.
So we're getting into impulse, Great. Well, let's move on to number 6. So how many times, what would you recommend coaches out there, athletes, maybe if it's an athlete that's not working with you, that probably should be, how many times per week should you speed train? If you're wanting to improve your speed, what's the frequency per week that you allot to focusing just on speed training?
If speed is an important element to you, it has to be at least once a week. Like we know, Vladimir Asurin put out a book in probably around 2008, and it talked about the training residuals. And his research showed that speed improvements, depending on the athletes. Now, in novice athletes, they fade much faster. Versus more experienced athletes. But I would set the floor at once per week. Most athletes, I would say, need 2 per week, and your novice, probably 3.
Right.
They'll struggle, I see it a lot. Novice athletes struggle on a day-to-day basis. And when I say novice, I mean underclassmen and under middle school to maybe high school, sophomore age. Struggle on a daily basis to repeat outputs. Mm-hmm. Like a lot of kids, we have the jump mats. Kids love to come in and jump because they can see their numbers. And daily, they will vary by 10 to 15%. Mm-hmm. Their CNS just isn't mature enough to reach that, have a repeatable output.
Yeah, depending on the age, it can still be myelinating neurons. I mean, so there's a lot going on there. Yeah.
You'll see kids, especially in that 12 to 14 range, there's a huge difference in maturation between each kid. Mm-hmm. Like you said, they're still developing. But I would set the floor at 1, 2 for most, 3 for the ones who really need it.
Right, and that kind of falls in line with NSCA recommendations. They recommend 2 to 4. 4 is a lot, but I can see 2 or 3, more than 3 speed training sessions per week. And then, of course, a lot of this depends on, are you in the competitive part of the season? Yeah. Are you non-competitive? How's it periodized? I think early, in the off season, like let's say it's for a football player and spring and the summer, you're training a lot of just maximal strength, heavy lifting. Then as you progress towards the competitive season, you get closer to August and the start of the season, the lifting tapers off a bit, but you're working on, power production, change of directions, maximal sprint speed, things like that as you approach the season. So that plays a role too. Maybe football wasn't the best example, but I guess just being a football player, that's what I relate to the most.
The question I get fairly often is, hey, does practice count? And I'm like, not really. We know based on looking at the NFL puts out their next gen stats. All the guys wear the zebra units in their pads. They're all tracked essentially every time they're on the field. So you'll see the next gen company puts out, hey, these were the fastest guys of the week. And it tends to be, there was a game where Patrick Mahomes was the fastest player in the game at 18 miles an hour.
Yeah.
Any healthy adult really should be able to sprint 17 miles an hour. Mm-hmm. So he really wasn't going very fast,
right?
But he was the fastest player in that game.
Yeah.
So a lot of kids are like, well, I played a game. Does that count as speed training? And it's like, no, you didn't hit that 95% threshold unless you had some type of insane breakaway,
But it's hard because then during the season you have to back off on the speed training because you don't want them getting overtrained. They've got life stress, they've got games, they've got practices, they've got studying late at night, whatever. And it's like, you're just trying to obviously maintain during the season.
But I still feel like that 95% threshold is very important. So a few years ago, I shifted my in-season philosophy away from we want to maintain strength. Because we know Vladimir's research showed strength gains lasted around a month.
Yeah, 2 to 4 weeks, you can maintain strength. If you just stop training for 2 to 4 months, you can maintain, or 2 to 4 weeks, maintain strength pretty well.
And then the older athletes, more developed ones, a month or so before they see any appreciable drop-off. Versus the speed element, which, within 3 to 5 days, you're starting to reach that degradation.
Yeah, I covered that question. I was going to ask you, we're skipping down, but detraining. Like you said, 3 to 5 days.
Yeah.
If you're not training speed, you can start to see drop-offs in your ability to hit that same maximal velocity. Starts coming back down towards baseline.
And if we know it occurs that quickly, and we also know that you need to train above your 95% plus of your maximal output, if you have the practice and the game, and you're not hitting that mark, well, whether you realize it or not, but probably on a neurological level, you're going to start to degrade.
Yeah.
And instead of 22.8 miles per hour you might be capable of, it might be 22.6 is all you're capable of.
Well, and I think, and maybe you'll agree with me on this, I think it's important for coaches and athletes to understand if I look at it this way, when you're in season, whether it's lifting, speed training, like with lifting, I'm a fan of keeping the intensity high, meaning using heavy loads during the season, but short sessions, lifting sessions, 30 to 45 minutes, cutting back the volume, the number of sets and reps. But you still want, if you want to maintain strength, you still need to be lifting heavy loads.
Yeah.
It's just you don't do as much volume and you don't have these long, drawn-out sessions. It's 30, 45 minutes, in and out, hit the basic, compound multi-joint lifts, get out of the weight room, do that a couple times a week, you'll maintain your strength. Same thing, I think, and agree or disagree with me, with speed training. Yeah, you need at least that one good speed training session, but you maybe cut the distance you cover, the volume of work back. But when you do that 10-yard sprint or 20-yard sprint or whatever you're working on that day, you need to be doing it full-on effort, max intensity. Yeah. It's just we're cutting the volume back to prevent overtraining.
Microdose both of those and hit them in the same session.
Yeah.
A smart strength coach would take that approach, early on, because it's heavily influenced by fatigue, hit your speed, and then we know, okay, strength is typically done pretty slow, hit that phase later in the workout.
Yeah.
You could kill 2 birds with one stone in the same workout.
Yeah. That's where you got to become a knowledgeable strength coach. So to be able to employ a properly designed and periodized workout program for your athletes. All right, so let's move into, another thing I wanted to mention, typically recovery maybe talk about how much recovery should you allow between speed training sessions? As far as how many days, hours do you recommend?
I'm a big fan of the floor at 2 days, depending on the kid and what we've done 3. Like, for example, our pro day guys, we'll actually have a 96-hour taper. We'll do a 4-day, so they can. I forget the name of the guy, but I was just reading a study where it talked about type 2X expression after an intense session is typically suppressed for about 4 days. So with those guys, we know March 31 is their day, so we'll work back 4 days from that. We'll back off all lifting. We might do some mild, high-speed plyometric work leading into it. But we're going to try and achieve that super compensation on the event day.
Right. And that's important. Strength coaches always work back from the event day, the competition or whatever. When you're designing a program, you start at, okay, when is the event? When is it they've got to perform? And then you work backwards with your program design. That's
like we're in an overreaching phase. I want their, like I told you about this. So, this kid typically he's reputed to be a 4.3 40 athlete. We're in an overreaching phase. So I should see his performance drop off, and then we'll deload to reload and achieve that super comp prior to his pro day. But I took him out and had him run laser time 40s, and it was, 4.5. He's about 95% of where he should be, which is great. Because then if he's at 100% or even 100 plus on pro day, who knows? Sky's the limit. But he should hit a pretty eye-opening time.
All right, so we'll move on to number 7 here. So periodizing volume. How do you periodize volume, intensity? We've got into a little bit of this already from day to day, week to week, month to month. I guess maybe talk about some of those variables, like typical volume in a workout. And this is hard for you to balance too, because you owning a private strength and conditioning facility, some of your athletes are working, especially if they're high school athletes, they have a strength coach at the high school they may be working with, then they come to you, you're kind of trying to fill in the gaps with what you do. You don't want to do too much because they've got practices, games, they're working with the strength and conditioning coach, they're in a weights program at school. So how do you balance all that, the volume and intensity with those athletes? Now the pro guys, I know you work with Harrison Butker and Karloftis, some of the Chiefs guys. You worked with Tyreek Hill before. When you have them in the off season and they're not working with the Chiefs head strength coach and assistant strength coaches, they're with you. So it's got to be, it's a little easier in the off season working with those guys.
Yeah, anytime, it's in isolation, it's easy to program. It's like you described the high school kids that are actually probably the most difficult because they're being pulled in so many different directions. Right. Not only with their school, but then their club teams. Because I'll be honest with you, in the past few years, the only sport I've seen still reliant on performance at the high school level, like for the high school team, is football. Baseball tends to be primarily recruited from performance during club season. Same with soccer, same with volleyball. Even track and field to an extent, indoors becoming more of a factor. And that's just a performance-based sport. Hey, here's here's the landmark we need you to hit. If you're here, you're recruitable. If you're not here, here's the level you project to. So there's a lot. They're being pulled in 100 different directions. So what I typically do is a kid will walk in, and I ask them, how you feeling today? They give me some feedback. And I say, okay, what have you done in the past 72 hours? And what do you have coming up in the next 72?
That's smart. That's good.
Give me that information, and I can plug and play based on your answer.
It's very important. You strength coaches out there, you need to check in with your athletes on a daily basis. You got to. Yeah.
And then, essentially we'll plug and play. For example, the quarterback from St. James University came in yesterday. He's like, hey, we're doing testing at school. I've got to run a 40 tomorrow. And I'm like, well, it'd have been nice if you had come in maybe a day or two instead of the day before, because I don't want fatigue to be an issue with you. But we know, okay, I can do some type of priming activity. So, and there's a debate on how long the effects of PAP last. I've read some research that said it could be up to 48 hours. So we'll do some priming activity, and I know that
that's hard for me to swallow. But
that leads to some arguments.
Yeah.
So we'll do some what I believe is targeting the CNS with very mild from an intensity standpoint in regards to like the muscle output, but things done at very high speeds. So we'll do some priming activities.
But not a lot of volume.
Correct. 10 seconds.
Yeah.
And I tell them, I'm like, look, you got 2 sets. It's 4-way line hops. There's 40 seconds of output. I want you to take 2 to 3 minutes rest in between as your floor. It's 2 sets. You're going to do that. We're going to do some mobility work. You're going to, foam roll if you need some outside stimulus for muscle recovery. Here's the foam rollers. Here are the Theraguns. We got some Venoms that you can use to heat. So, yes, I recognize that the placebo effect is in use here, but you feel good, you perform good.
Right, that's true. And you kind of mentioned rest periods between sets. That's another thing I meant to bring up. When you have athletes doing sprint work, what's a typical work to rest ratio? What type of rest period lengths do you typically have? Because one thing I commonly see with athletes or sometimes it's strength coaches is they don't allow adequate rest between sprints, between drills, and then it turns into you've got fatigue setting in. We're not trying to train endurance here, so you want to have an adequate rest period. So what do you typically recommend? What you just said is probably the most aggravating thing I experience on a day-to-day basis. High school kids will come in, and I'm like, because, in a private setting, I'm working with multiple people at one time, and I'm like, hey, here's what you're being prescribed right now. I need you to go do this, and then check back in with me. And I'll turn around, and 1 minute later, the kid's back, and they're like, oh, I knocked out 5 sets. And I'm like, no. How in the world did you accomplish Stick
this?
to your rest period, which you would recommend 2 to 3 minutes.
What I tend to tell them is for every second of work you are doing during the set, I want 6 to 10 of rest.
Yeah. Yep.
So
about a 1 to 10 work to rest ratio, and that actually falls in line with the NSCA guidelines. Yeah, 1 to 10. Yep. That's good. It's like, I know you want to get this done, you want to get your workout over, but no, there's a reason that you're having these prescribed rest periods. It's so that it allows that phosphocreatine, that PCR ATP energy system, you're rebuilding that in between sprints or in between drills, and you want to have those fuel sources readily available so you can give the next sprint, the next drill, that next set, if you will, that you do, that max effort. Yeah.
We keep about 24 kitchen timers in a bucket on the training floor. And especially new kids, I plug in. Your floor is 90 seconds. I know how long a set should take. Your floor rest is 90 seconds. When you finish, you hit start. It will beep when you can go.
Right. You got to put them on the timer. Yeah. All right. We talked about detraining. Kind of skipping ahead here, some of the questions. So we know, like I said, with detraining, you can lose speed. You can start returning to baseline in 3 to 5 days. Now what about overtraining? Now we know that speed is highly sensitive to overtraining. So let's say an athlete's doing maybe way too much resistance training, too much volume, too great of intensity, it's not prescribed well let's say they're high school, they're too many days back to back, not adequate rest. So they're doing a ton of resistance training. And this goes back, Dr. Andy Fry here at KU has research going back to the 90s on the impact of doing too much resistance training, being overtrained there, and how speed is the first performance variable that goes. You see a reduction in speed. And they've shown, and this is going back to some of his research, that 40-yard dash times may be reduced by up to 0.2 of a second in overtrained athletes. And again, remember, 0.2 doesn't sound like a lot, but if you're running a 40, and let's say you're getting ready for the combine, you're going in overtrained, and you normally run a 4.3, and then you run a 4.5 on that day, draft stock could be falling. So it's a big deal. It will be falling. I mean, And so how do you track or monitor if overtraining is occurring with your athletes so that they avoid seeing a decline in their ability to achieve and maintain that max speed, that max velocity? I mean, I guess, how are you tweaking the program to avoid overtraining?
So, the day-to-day check-ins, and then I'm a big believer in using the vertical jump to check output thresholds. And I know if a guy isn't hitting 90%, which I'll be honest with you, like our pro day guys right now, they're not. We're in a purposeful overreach phase. I want to see their numbers down a bit because I know then when we start to taper and they're recovering better, we should see that super comp. So I'll use the vertical jump. I know Dr. Wagner and Sparta, their charts match the ones I came out with years ago whenever it comes to vertical jump threshold, telling you how an athlete's recovered. And we jump every week. And then we're fortunate in that we have a very good recovery therapist and soft tissue guy on site. So I'll send them to him, like they're actually there right now with him. So there's that element. We work on fueling, rest. We're big on promoting, hey, I want you to go and I want you to, are you checking this box? Are you getting 8 hours of sleep a night? Are you fueling your body properly? But as far as like monitoring for overtraining, almost every sprint we do now is timed. And I know, okay, if you're running a weird time that looks very slow compared to where you should be, okay, we're in that either overreach or we're hovering around overtraining.
Right.
That's our approach with it, and we're fortunate because we're a private facility. We can individualize to that level. I recognize a team setting might not have that, but again, that's where that vertical jump can come into play. I mean, that takes 2 seconds,
right?
And then hey, you're under 90%, and I've given you 5 attempts to get there, and you're not reaching there. You are in a stage where you need some recovery. We need to emphasize recovery with you. We're actually going to pull you out. We're going to pull 80% of your volume on. You get 1 set and then move on.
And this is great that you assess. Like I said, I can't hammer this home enough, but it's like I think so many coaches are focused on putting the athlete through the program and trying to progress them and overload them and, the whole specificity, overload, progression, all of that. But it's like they don't take time to assess and see, well, what's actually going on here? Are any of my athletes regressing? Are they, like you said, overreached or overtrained? Because we want them progressing, right? It's like they don't take time to assess. So that's an issue I have with, in a lot of cases. I think there's a lack of assessment.
Yeah,
but you're doing these daily check-ins, which is great. I mean, it's really awesome.
Some coaches are just like you said, stress,
Right.
and then it becomes, well, hey, guess what? The athlete is recovering now because there was an acute injury that occurred because you overloaded them with too much stress.
So it was like stress may lead to regress. It's like you want stress to create an adaptation, and that adaptation needs to transfer to the field, the court, the track, whatever. But again, it's this balance. Just like we talked about with the body, you want some mobility, you need that, but you also need some stiffness, right? There's this bell-shaped curve, right? You want it to be right in the middle there. All right, so let's move into talking about sprint biomechanics and technique in each of the different phases of sprinting. So we're going to pull up some pictures here, look at the start position, acceleration phase, transitional phase, the max velocity or top speed phase. And then Coach Potts will provide some kind of practical tips, coaching cues, and things that he might commonly correct in each of these phases. All right, so Coach Potts, let's take a look at these different phases of the sprint cycle. So here, we've got these athletes lined up in the starting blocks. You want to talk about, they're just what form should you take on if you're going to be starting in the blocks?
This is probably coaching cues that we're seeing here. I believe that's Chris Lamontre here closest to us in lane 8. You can see his shoulder is stacked over the hand versus the Jamaicans, which tend to have that shoulder out in front of the hand.
Now, I know I typically coach my athletes like that. Hands under the shoulders are a little bit wider with the shoulders over the hands.
Yeah.
That's how, when I was a strength coach, that's how I coached it, more like the Jamaicans.
Yeah, which, it's from an efficiency standpoint, he probably is carrying more load in his hip, knee, and lower leg than those other guys, which he's going to have to move. He's going to have to transition that load out front.
Greater inertia to overcome.
Instead of starting with it already in an advantageous position.
But also, when you're leaned more forward, you look at the Jamaicans again in yellow and green there, lean more forward, you're really going to have the strength to propel yourself out at that 45-degree launch angle and be able to deal with the ground reaction force of that zero step, that first step hitting the ground.
And you could see him, looking at the musculature of the arms, they obviously seem to have greater muscle mass, more definition, versus him, which is more of a lean guy. And honestly, he's probably a bit taller. I'm guessing. I don't really know his height or his weight. But if I remember right, he's a taller, leaner guy, which could, could be limiting him.
Right. So in general, we've got hands underneath the shoulders leaning slightly in front of the hands. Let's talk about hip position. So you see, obviously, the hip position. Hips are positioned higher than the shoulders. You see anything through the hips there with the different athletes?
I believe in track you can get away with that because you have the blocks providing a horizontal platform to project off of versus like a 40-yard dash where your foot's on the ground.
And we'll look at that in a bit.
So they've got the high hips. They have 4 points of contact. And I believe if you look at the the Jamaican sprinter closest to us, I think he has his foot placed higher up in the blocks, which would help with that horizontal projection versus if that's Lange, he's probably going to have a bit more vertical. And then you can see, I think, the height difference. That's probably Usain Bolt.
Yeah, he's there in lane 5, it looks like, in the middle, with the hips elevated the highest.
With him being 6'5", anatomically, he's going to... Yeah. And I believe Lange might have been around 6'3", which would put him a bit taller, which would probably explain the differential there. But yeah, these are all guys who have been well coached and are obviously the 1% in their sport.
Right. There's not a lot to correct there. They know how to get in the blocks, but that's what it should look like.
It becomes an argument like, do you want to correct some of this stuff?
Right. And then if we talk about, again, if you're a coach trying to set up your athlete in the blocks, it's like, maybe let's talk about the front knee angle versus the back knee angle. So the foot that's back versus the front knee. So typically, I know, the front leg, you're looking at about a 90-degree angle, and that rear leg, the knee angle should be about 120, 130 degrees. Yeah. So it's a little more open. And if you see those angles, you're probably set up pretty good coming out of the blocks. And I know, like we talked about, everybody has some different preferences with, the distance between the lead leg and the rear leg. But yeah, overall, the 90 degrees on the front leg for the knee and about 120 for the rear leg.
That high foot placement you see with the Jamaicans, that's something that I'd like to see used more in America. I know Coach Driscoll at Blue Valley, before he passed, he and I actually had a pretty decent discussion on Twitter about how he was going to start having his athletes, the ones who were strong enough to hold themselves, start using a higher foot placement in the blocks. But unfortunately, he passed away and was never able to try it out. But yeah, it's something I think would lead to better projection. That it makes sense.
Yeah. So I think the next one we'll go into then is figure 2,
a zero step.
Yeah, so here's your zero step, that initial takeoff or drive out of the blocks. Of course, this is Usain Bolt here. So maybe just talk about his mechanics, I guess, just working from the feet up. Maybe we just start ground up.
Yeah. So you can see he's got a good drive angle. He's a bit higher relative to the shorter sprinters, but that's an anatomical thing. Right.
And what drive angle typically we're shooting for coming out of the blocks, relative to the ground?
Yeah, 40, 45 degrees.
Right.
That guy in blue with the headband may be at 40 versus Bolt, who's higher, a bit closer to 45. But for me, what I'm looking for is his, what I call landmarks. So you can see his elbow is slightly above his shoulder, so he's had a very violent arm action there, and it's being reciprocated down through the trunk with the knee drive. He's reached about 90 degrees of flexion there relative to the trunk. Shin angle is back to apply that punch into the ground through the ball of the foot. He looks honestly really good.
Right. Yeah, and that positive shin angle, that's something to look for. And like you said, how do you, what are some cues? If an athlete is struggling, one thing I see with, let's say, younger athletes that are a little bit weaker, when they project and drive out of the blocks, that's one of the things I always look at is that angle relative to the ground. The weaker athletes, they come up. They're more vertical coming out. That's one of the main things.
They cut that acceleration phase.
Right.
Short.
And that's where, it's like, okay, we got to get them stronger. If they're coming out of the blocks and they're almost standing straight up, you're not going to be accelerating very well out of the blocks. So.
Once you've oriented yourself vertically, all that, that ground reaction force that should be coming down and back is all vertical. And if you haven't built up the necessary momentum, you're going to be struggling to achieve high speeds.
Right. Any cueing with, as far as driving back into the blocks with the legs? Anything that you mentioned there, or?
So I do tell, like, when we're doing the setup, I do tell them, like, load distribution, don't be at zero load on your back foot. Because you do want to project, you got to have that, basic physics. For every action, there's an equal and opposite reaction. You do got to have some weight on there to project back, to drive that leg. You don't want to worry, you don't want to rely on the hip flexors just to do all the work. You want some ground reaction force. So whenever I cue kids in that zero step, now traditionally I'm working with guys in a 3-point, and I use a gun analogy. I'm like, your down arm is your trigger, and that knee on the swing leg is your bullet. You want to pull that trigger, and you want to fire that bullet, and it has to be two violent actions that occur in sync.
Right. And I think another thing is looking at that knee drive from that rear leg, too. You don't want it to be, and looking at, are they maintaining that rear leg? With Usain Bolt here, he's got the right leg forward, but where's the foot relative to the ground as they're driving the knee up? Is it coming up too quick, or is it projecting out?
So you can see, I think he's in a bit of plantar flexion. A lot of the Jamaican, and probably most, are taught a toe drag because they want to keep
That's kind of what I was getting at.
A low shin angle. So he's probably setting, I'm assuming, I don't know what race this is, he's setting himself up for that toe drag with that plantar flexion. But you can see that drive leg. He's dorsiflex there to create the shorter lever, cycles through a bit faster.
I think a lot of guys, they use that toe drag to try to create more time to produce more force coming out of the blocks, and like basically a greater impulse. But do you agree with it or not? Like having somebody toe drag that back leg. I don't either. We're on the same page about that. I've never thought trying to drag, kind of scrape that toe along the ground.
And Stu McMillan, one of the coaches here in America who works with a lot of high-level sprinters, he's not a big fan of it. He's like, anytime you're creating friction, it's a braking force.
Right, it is. Yeah.
But it works for them. They probably started it at a young age, and that's what they're accustomed to. It becomes that yin and yang of altering their mechanics.
Right.
If you coached him out of it, are you going to see a negative impact on performance?
That's true.
High potential for that.
All right, so we'll look at the next one here. And we don't need to go back to it, but I should have mentioned, in violent arm action, right? So, because the arm action is often overlooked, but, really propelling that opposite arm forward of the leg that, so if you're coming out of the blocks with the right leg driving up, knee drive with the right leg, then that left arm should be violently coming up and you're throwing that left arm back. I think you mentioned it, or right arm back in this case. I think you mentioned it. Now let's look at, you work more commonly with athletes coming out of this
the 3-point
stance, because I know, like I said, you work with a lot of the guys getting ready for the combine, working on their 40. Maybe we talk about the start leg here, because I know, now you mentioned, I know when you were working with Tyreek Hill, you said he actually had his lead leg, he had the wrong leg forward, and you found some differences in his times.
Yeah, there was a difference in his outputs whenever we would change the lead leg. He was comfortable with one leg forward, so that's just whenever he would. And we weren't working on running a 40. This was on
just
field.
Coming out of a 2-point stance, like as a receiver,
eating up the ground between him and a defensive back.
Right.
So, again, we're fortunate to have a 1080 unit, so there's no human element involved in our measurements. I hook him up to it, and it's, hey, let's do a few reps, you coming out of your normal.
As an upright 2-point stance as a receiver, right?
Positional stance. And then, all right, well, let's try the different leg. And, we saw a pretty substantial difference in his ability to close that gap.
So which leg was it he felt comfortable with? Do you remember?
I want to say he normally came out with the right leg forward, and we switched to the left leg.
So with the left leg forward, it didn't quite feel as comfortable, but he actually had faster running speeds coming off the left. Okay. And this is important, figuring that out. I know for me, my stronger leg, and that's the leg you want in front, was always my right. I think for a pretty significant percentage, there's some studies on this, pretty significant percentage of the population, though, it's actually the left leg in front. But
most of the population is right leg dominant. Now, dominant doesn't mean stronger, it's the coordinated one.
Right.
So typically what I ask kids is, what foot do you kick a ball with? The overwhelming percentage say right leg. And I'm like, okay, then you need your left leg up as your drive leg. And then if they struggle with that concept, it's like, okay, here, we got the jump mats. Balance on your right leg, jump in the air. Balance on your left leg, jump in the air. What's the differential?
Yeah. All right, so talk about a little bit about the difference here. We looked at the start coming out of the blocks, but the start position, for these guys, like I said, that you work with, coming out of the 3-point stance.
So you can see he's got, it's a bit higher shin angle on that lead leg. I know Cam Joss is big in having the back leg be almost parallel to the ground. He feels like athletes, in his experience, have got better horizontal projection accomplishing that. This guy isn't there, but you can see there's a difference between the drive leg and the swing leg. His shoulder is minutely in front of the hand, so he's could probably work on that. Maybe he had an injury on that right side. Hand placement is there because in the 40...
You say you want him leaning forward more. So on the hand that he has down on the ground in the 3-point stance, you're wanting that shoulder, you're wanting him leaned more forward.
I would probably like to see him a bit more over that, in front of that.
Right.
But again, maybe he's had a shoulder issue. I mean, he looks like a bigger guy, so I'm guessing he's like a mid or an edge guy. So he's probably weighs a decent amount. Maybe he just struggles with that right hand to hold that load. And then the up hand, it's in a good position because in the 40, you are what initiates the timer, not like in track and field where it's the other way around. So you don't want to give away. Like if a kid has their hand cocked up and the first thing that thing does is drop, the timer's keying on that, and essentially...
Yeah, you're kind of hiding that backhand by the hip, but it's still in a good position to swing forward violently and help you project out.
Yeah.
So,
And I know, like Pete Bomarito uses the cue, like block the sun, like you want that swing arm to come through and get out in front of you. So he's in a good position. And it could be like we talked about the shin angle. There could be ankle mobility issues that are a factor in there as well.
What do you think about knee angles?
Yeah, like I said, Cam likes that low shin angle. I've seen good results cueing that low shin angle to help them project out. So he'd probably have to sacrifice some distance between that lead foot and the swing leg. But again, it goes back to the jab versus haymaker. Maybe that could be beneficial. That's something that I'm assuming his coach might have worked with him on whenever they were prepping for this.
All right, we'll go to the next figure. So the takeoff and drive here out of this three-point stance. How are you coaching your athletes here to come out? What are you looking for? What are common errors you see?
So I actually know who this is. This is a running back for the Chiefs. You can see he's got some pelvic tilt. And unfortunately, I'm not.
Yeah, his left ASIS, anterior superior iliac spine, the left part of his pelvis is collapsing internally.
Yeah.
I mean, you can see it.
Yep. So he's probably, I'm assuming, he's not the tallest guy in the world. He's pretty forceful, pretty powerful. So he's got a bit of external rotation, applying pressure from that big toe into the ground. His shin angles, I think, are actually pretty good. But you can see he has a slight rounding of the back. His pelvis isn't at neutral.
It's really just rotating towards the right in that transverse plane. Yeah. I mean, you can see that pelvis essentially rotating. Well, and it's going to really cause a loss of transfer of energy from the ground up to his core and out through his arms. You know, when you have that much pelvic rotation, you're not going to efficiently transfer ground reaction forces.
Yeah.
You know, when you push off the ground reacts with force back up through your body. You're going to lose some of that there. When you see the pelvis doing that, it's not being transferred through the core and out to the limbs.
And we know he ran a time in the 4.6s, which in the broad spectrum really isn't that fast for a skill position guy, versus a guy like Chris Johnson, who was in the 4.2s, Ezekiel Elliott in the 4.4s. And that's probably where he lost a bit of time, is that
right.
I
mean, now his head position looks good. He's looking down, he's looking at the ground, he's not up. You never want to come out. Again, if you look up with your head, you're going to stand up, and then your launch angle is going to be poor. So he's coming out low. Yeah, shin angles look good, all of that. The head placement.
That hip and trunk, the low back and the hip.
Rear arm, he's looking, arm action looks pretty good. What do you think about that lead arm? A little higher maybe with it, throwing it a little higher?
Potentially. It's probably because, he's rotating, so he's not reaching the highest point he could in terms of hip flexion with that left leg.
Because he's going to have to counter that pelvic rotation with that front arm.
Yeah, so he probably subconsciously shortened that action to make up for that rotation of the hip. Just anything
you might do with him to work on that? What might you?
Probably a lot of anti-flexion, trunk training, maybe some soft tissue work on the hips just to make that a more natural thing to be in line with the pelvis when you're driving the knee instead of rotating.
Yeah,
those are two big things.
All right, we'll go on to Figure 5. So the acceleration, again, we got Usain Bolt here. I mean, why not have the world record holder in the 100, right? 9.58 seconds in the 100 meters. Why not show him here in the acceleration phase?
So this looks like late phase acceleration. And again, he's hitting that landmark, elbow to shoulder. The swing arm on the front side is in a good position. He's reached, I would say, over 90 degrees relative to the trunk with his hip flexion. He's dorsiflexing the foot to create that shoulder lever for better turnover, and he's applying that force through the ball of the foot, that hammer.
Right, powerful hip extension, good arm action. You see, I look at his arm action. You look how far back, how high that right arm, that elbow being above the shoulder joint. And it reminds me, I got a buddy, Jesse Grove, good buddy. We go way back out in Dodge City, Kansas. He ran track down at University of Houston, and he ran for, they had Leroy Burrell and Carl Lewis, and Tom Tellez was a track coach down there. And Tom Tellez has a lot of really good information and stuff that he talks about with arm action, which is often overlooked. And, you know, he really talks about, you know, staying loose through the shoulder, but really driving that arm and that elbow back and up. And some of this, you're going to be initiating stretch reflexes and through the shoulders. And the arms not only are counterbalancing the legs, you know, the opposite arm and the arm that's up is going to be opposite to that lead leg. But really, the faster you're moving those arms, it's going to help increase your leg turnover and stride frequency. So, you know, arm action, I think, is, and we talked about it on the ride over, is very important and often overlooked.
Often overlooked, yeah. So, like you'll see a lot of kids in my experience. I see a lot of kids who aren't reaching like what I would call like optimal positions.
Do you cue them just hip to cheek?
I don't. I cue the shoulder at or slightly above. I'm sorry, the elbow at or above.
Yeah, driving that elbow back and up, back and up.
Shoulder is like our pivot point, and I'm like, I want your elbow at or above that, because then you've got that reciprocation of the hip flexion.
Yeah.
Which you can see. I mean, that's right there's a perfect illustration.
And you'll see, it's funny, you see, it's like you want to be fast with those arms, but you don't want to short stroke it either, and you don't want to also like overreach with the arms. Because, you know, typically what happens, and I can specifically remember a 40 that I ran when I was in playing arena football. I came out great the first 20 yards, then late acceleration transition, I start standing upright, and I started overstriding. And, you know, anytime you're overstriding and your foot is landing in front of your center of mass, it's a braking force and it's going to slow down. You want that foot to land, like you said, 4 to 5 inches in front of your center of mass, close to just underneath your hips. But I think one of the reasons I was overstriding when I look back at that film is, you know, my arms, I was overemphasizing the arm action, and I was coming with that lead arm, my hand was up here like above my cheek, like it was too high. And then that was causing my legs, the stride length, to be too great, you know? Because I think
your body has two choices. It can either start to rotate to account for that, or start casting that lower leg to make up the time you're spending in that arm swing.
And then I think you get into the overstriding and things like that, and then you kind of maybe put you at risk of some hamstring injuries, some other things, because you are overstriding, you know? And I realized it when I looked at it. I was like, man, that just didn't feel right. So you don't want a short range of motion with the arms, but you don't want to over exaggerate either. Just, you know.
And I feel like an athlete's pec minor plays a big role in that, and what's optimal for them.
And also scapulothoracic mobility too. The scapula's got to be moving correctly on the backside as well, that shoulder blade. So it's not only the glenohumeral joint, the shoulder, having adequate mobility through there, and it's also that shoulder blade moving along the rib cage on the backside. So a lot of things going on there. Anything else you want to point out?
I feel like you see Bolt, he tends to maintain like a neutral pelvis, and he's projecting well like forward, versus these guys in red and blue, and I unfortunately don't know who they are, but they seem to me to have a bit more rotation.
Yeah, torso rotation. You can see there the guy in the blue. He's got some spinal rotation towards the left there, so he may have some wasted energy. And that's where, again, you want to look for your athletes. If we're looking at them coming head on, you don't want those arms crossing over, right? The center line of the body, because then you're losing that energy, that transfer from the ground up, and you don't want that torso rotation. So you probably do some like anti-rotation training and things like that with the core.
We finish each workout with what I call trunk or core. And it tends to alternate between flexion, extension, depending on what our emphasis has been for the day. Flexion, extension, anti-flexion, anti-extension.
You think like call-off press, like anti-rotation?
Yeah. Or even one where I try and incorporate a lot into like hindbrain training where it's just instinctive, reflective. So I'll have guys, we put them up in like a pull-off setup, but they're not holding like a band or a cable. I have them hold a stick, and I will take the band. They have to close their eyes, and they have to just react to what they feel, the stimulus. And I'll pull that band away and release it, and they've got to try and stay rigid against that rotational force.
Right, so let's demonstrate. So I'm holding it here. I got my eyes closed. I'm holding like a PVC pipe or a broom.
I have you try and get a decent gap between those two.
Okay.
And let's say I'm on your left side.
Okay.
So I would take a pretty thick, like medium thickness
resistance
band or 41-inch band, pull it back, and I'm like, hey, you're trying to fight what you feel. And I would let it go. And obviously, if it's pulling you like 4 to 6 inches, well, you're not strong enough.
Trying to prevent my spine and core from rotating, right? Because you don't want that rotation occurring in the sprint cycle. So, and then one other thing I think we might mention here, the last thing before we go to the next figure, is that in this acceleration phase, you'll notice that overall, look at the torso angle relative to the ground. You know, you're going to have still in this acceleration phase, which is up to about, well, if it's a 40, 20 meters, but in 100 meters, it can be up to 60 meters.
Oh, yeah.
You're in an acceleration phase up to about 60 meters.
I would say 60 is common.
Right. And so the torso angle, you're not going to be upright yet. Look at his torso angle. It's still, he's still leaning forward, all right? Which you're going to see that start to change, the torso angle.
His hips are behind his shoulders. He's still, like I said, but he's upright enough that this is probably late acceleration.
Yeah.
Moving towards transition.
Which we'll go to next. So we'll move into the transitional phase. So you look at athletes here now. This is after that late acceleration phase. Now look at those torso angles. They're all more upright.
Yeah. And actually, the guy in red's probably a really good illustration. His hips are still behind his shoulders, so he's in that transition phase. Same with the guy out front, but you can see he's transitioned a bit faster. He's a bit more stacked shoulder to pelvis versus the guy in red. And again, this stage probably only lasts about 3 steps.
Right.
It's a very short window.
You know, and this is where, again, you know, that late acceleration, the center of mass, the hips are still a little low, torso angle, you're inclined more forward. But here now, that center of mass, you're starting to raise it and become more upright.
Yeah.
And man, look at who's in the lane closest to us in the white there. That is like big time backside mechanics.
Yeah.
That's an anterior pelvic tilt.
Which probably explains.
So the guy closest to us, that's like a hamstring injury waiting to happen. That's, I mean, anything to say about his mechanics? The one that's literally closest to us and all white there.
It probably illustrates why he's in last. He's got a long stride cycle. He might have a history of hamstring injuries based on those positions.
I mean, that rear leg, that right leg, the amount of hip extension he's got going on there, that's a lot to recover and gather back up to bring that right leg.
Like, it's rare to see true, like, triple extension, but he's hit it.
Yeah.
And it's going to be slow because of that, the recovery cycle.
Anything else? Man, I'll tell you what, whoever's in lane, the guy that's in the lead there in white, good arm action there.
Good.
Look at that arm action. Looks really good.
Yeah, about to the eyeballs.
Yep. The hand is up by the eyes.
Yeah.
Relaxed hand. You know, he's not running tight.
And he's reaching, again, he's in that transition period, so the arm action is going to not be as exaggerated as it would be during acceleration. He looks good.
Which, like you said, probably explains why he's in front there in the transition phase. All right, so we'll go on to the next one, which is this last phase of the sprint cycle. So here are you've accelerated, you transition from the acceleration now into this maximum velocity or top speed phase. So we're going to talk about what we see here.
Yeah, so you can see, and in my opinion, first thing I kind of see is maybe a bit too much rotation in the trunk.
Yeah, we've got some, you can see the china. I mean, we've got some spinal rotation towards the right, so he's over-rotating a little bit there.
Which probably explains why he's known as a very good guy out to 60 meters, but then
he's a good accelerator, good at putting force into the ground, but maintaining top speed.
But this was a pretty good, I mean, he's out front. It's a good picture from this lateral view. So, but you can see like his shoulder girdle and his pelvis, pretty stacked. You know, he's probably not in quite full top end yet because the pelvis is maybe slightly behind there. But it's a good picture for what we're trying to illustrate. So he's pretty stacked vertically. In my opinion, he might be casting that lower leg. Again, might explain why he, from that 60 to 100 meter zone.
Can you kind of explain what that is?
So
casting.
It's hard to see his foot. You can only see the very top of it right here in this photo.
The right leg.
Yeah, see how the foot's out front, and I can't tell where he's at relative to the track because we can't see it. But the concern would be that he might be landing midfoot versus the forefoot.
And I would think right there, I mean, you look at how the shin is swinging a little bit in front of the knee. He may land too far in front of his hips, honestly, which would apply some braking force to his body, causing him to decelerate in this top speed phase. Because if you look at, I mean, you don't want that shin swinging out in front of the knee. In fact, at this phase, this late flight phase, late swing phase, those hamstrings are going to be contracting eccentrically to control that swing of the shin on the lead leg, the right leg. And he's got, it's swinging out a little bit. I wonder, I wish we could see where he was going to land with that right leg.
It'd be great to have this in video, slow motion video.
But, and another thing I see, look at his face. He just looks tight.
Tense,
I mean, he is, you know, you want to see relaxed jaw, cheeks bouncing up and down. Like I said, when you're putting force into the ground with the foot, you want to be stiff, right? Like you said, using a hammer on the ground. But when you're recovering and then bringing that leg off the ground, you need to be loose. I mean, so it does look a bit tense.
Yeah.
And then even through the hands.
And that could explain that over rotation through the trunk.
Now with hands, I mean, this is an argument too. You're going to have a longer lever here if you have the hand open like this. Or, you know, you can have it slightly relaxed. I know, like Tom Tellez, going back to him at Houston, it's either way. Just as long as your hands are relaxed and you're not, not like trying to hold on to a gun like you're gripping. Yeah. So you could have a closed fist, and it's hard to say, and still be relaxed, slightly closed. But just looking at his face, he looks tight.
I like the fist on the guy. It looks like in second place. It looks like, he's got his thumb set on top of it.
Red top, blue shorts.
It looks like he's got a bit of an open.
Face looks more relaxed.
I forget the coach, but the analogy that I've heard used before was pretend like you're holding like a potato chip in between your...
Right. Just enough to keep a hold of it, not to break it.
Right.
Yeah. Right. That makes sense. All right. And then this phase, one thing to mention in the top speed phase, this is where it's very important to have that speed endurance and not decelerate. This is where the athlete that can maintain speed the longest during this phase is going to win. Now, if he would start to decelerate here and not be able to maintain his top speed, the guy in second could catch him before they get to the finish line.
Based on what we were just discussing, could have happened in this race. I don't know. I don't know when this race was. I do know that he has gone sub 10 in his career. So I don't know if that was in this race or not. I know he's known for being a great accelerator and then lose. He's not the tallest guy, so, limb length again plays a role. Guys can catch up on him. But yeah, for the purposes of illustrating that max velocity, he's out front, so it's good from this lateral view. At one point he probably had a bit higher hip flexion there. And then we talked about the rotation and the casting of the leg.
Yeah. Well, let's go ahead. We'll move on to, we've got a video now, or not, that's coming up in a bit. One more slide here. So this is just looking at differences in mechanics between, youth, female versus male, elite sprinters, Major League Baseball players, NFL receiver, professional soccer players. I know you said some of your athletes were involved.
Yeah. A couple of my athletes are in this silhouette kinogram. So I guess the biggest thing is looking at foot strike, arm action, things that become inherent because they're so common in the sport.
Torso angle, and look at the professional soccer player. What's up with the head there?
Yeah.
The head and neck are totally hyperextended.
Maybe they're used to being in a chase mode, and
just
they're just
totally hyperextended.
But to me, like the baseball player and the receiver have a pretty good illustration of how the sport affects your common movement pattern. Like receivers have an obstacle in front of them versus a baseball player who, hey, you got to put your head down and get to first base. So that, you can see a little bit of difference in the angles there. But then you look at the elite sprinter who, again, touchdown is occurring just in front of the pelvis to take advantage of that stretch.
Got really good hip flexion, like on that right leg. Look at that knee drive.
That's a top speed, like those are top speed mechanics versus the Major League Baseball player, the receiver, who maintain almost what's more of a late phase acceleration during what they perceive as top end.
Right. They're stuck more in that position of, and that's where you see differences in the torso angle. Like you said, the elite sprinter, look how stacked they are, the shoulders over the hips. And then look at, as the leg recovers, that right leg, and you swing it forward, the heels are almost clipping the butt cheek.
Yeah.
So that's, creates a shorter lever, easier to swing that right thigh forward and drive that knee up nice and high. I mean, you see that in elite sprinters. I mean, that's really good. Yeah,
that cycle of hip flexion occurring again on the very last one in the elite sprinter versus like the NFL receiver where you can see like the knee is still, they're essentially almost next to each other versus the sprinter who's already out front. Same with the baseball guy, his knees are essentially... All of the ones that aren't accustomed to being, or like sprinting isn't their sport, tend to be in that late stride cycle, their knees next to each other. And the 16-year-old guy is actually, he's even behind his shoulders.
Yeah. Yep. All righty, we'll go into looking at this video. So here's one of your athletes. Who is this again?
This is Echo Boydo. He's a cornerback out of Kansas State. He's a pretty fast guy.
Great foot striking. They're landing on the ball of the foot. We talked about you don't want to run on the toes. You want to...
Yeah, let's run that back all the way. And then... So this is actually the after video. Where we've worked on his mechanics. If you have the other video, the previous one, you can see for whatever reason, he would overstride only on his right leg.
Oh, that's interesting.
So I don't know if that other video...
Yeah, we don't have the other one. Do you want to run this one back one more time and go through it? Just, is there anything you want to point out here with his mechanics that, it looks really good to me.
Yeah, so this was after we had done some wicket runs to work on his spacing. He wasn't casting that lower leg on the right side out as far anymore. But yeah, in the before video, his left side was good. He was striking the ball of the foot, but his right side, for whatever reason, was coming down too far out front, and he was heel striking, and it was chronic. It was a consistent issue.
Interesting.
So we did some work, and some video feedback was huge for him, so he could see it.
But yeah, he's got nice and stacked, upright, great arm action. Look at his arm angles, 90 degrees, driving that elbow back.
Which is funny because he did not run track.
I know. He looks like he ran track because you can just see it when somebody was a sprinter. But yeah, his arm action looked good. Those angles look good. His striking the ground, just slightly in front of his hips.
Yep. Letting the calves contribute to the propulsion, yeah.
Right, and you see you strike with the ball of the foot, and then that heel almost acts as a spring. Yep. You strike with the ball of the foot, heel comes down, hits the ground. That's going to stretch the Achilles tendon, the calf, store some elastic energy in there, and that's going to recoil like a spring and help propel you back off the ground. So, yeah, it looks really good. Yeah. Really good.
He responded well.
Anything else you want to point out? I mean, we've had a long discussion, talked about a lot of things. Any other comments?
No, I mean, I feel like we covered all the major, things that needed to be covered in regards to common mistakes we see, ways to adapt and overcome them.
Yeah.
Feel like we gave the audience some things that they can keep in mind when they're out doing their own speed training or working with someone on it.
And my students might have a quiz or some extra credit. Who knows what I'll assign over this. And I also want to thank those of you that are watching on YouTube. I hope you're getting some value out of these videos. I got to say it. Like, subscribe, share videos.
Send it to your friends.
Right, all that. So, well, thanks for coming in, Coach Potts. One other thing before we go, how can people contact you if they have questions about training, they want your training services? How can they reach out to you?
Email is probably the best method. Coach Potts, Potts, at TopSpeedTraining.com. Social media channels are pretty much all TopSpeed LLC. We're on Twitter, Instagram. TikTok exists, but there's maybe 2 or 3 videos on there. And then we have a Facebook page. But again, email is probably the best method.
Yeah, and if you have any questions for me about the KU Exercise Science Program, you can email me at jtaylor@ku.edu or call me at 913-897-8516. Thanks for watching this episode of Fitness Facts.